All right, ladies and gentlemen, without too much further ado, welcome to this meeting of SVAS. The topic is the best deep space objects of the summer sky. With your permission, I'll be sharing and starting a slideshow. All right, so here we are, and fall is coming up. The summer is ending, as hard as that seems. This year is pulling into its final stretch. Autumn begins in September 21st, more or less. And here are some of the things to look forward to in the autumn skies. Here we go. Perhaps the most famous of all autumn objects, and indeed one of the most famous of all objects, period, in the sky. This is the Andromeda Galaxy, Messier number 31, with its two companions, Messier 32, just above the spiral, and Messier 110 beneath it. It's almost kind of a parallel to the Milky Way galaxy, just as we also are a spiral galaxy with two large orbiting satellites, the Magellanic Clouds. Andromeda is an even bigger galaxy than us with two large satellites. Uh, M31 is about 2.5 million light years from us, but it's approaching us, and our two galaxies are going to merge in about 3.75 billion years. Now, the Milky Way is a above average galaxy in terms of size. It's big. It has roughly 400 billion stars. But Andromeda is even bigger. Andromeda has about 1 trillion stars within the spiral. That doesn't even count the two satellites. Uh, Here's a label, the map of the system. There's Andromeda itself, Messier 31, Messier 32, and Messier 110. For the benefit of those who are wondering what this M number means, M stands for Messier. Charles Messier was an astronomer in the 1700s. He was a comet hunter, and he did, in fact, discover 15 comets or so during his lifetime. However, while searching the sky, he would kept finding these faint, fuzzy objects in his telescope that he first thought were comets, but they turned out not to be comets because they never move against the background sky. Their positions in the sky were always fixed and unmoving. So therefore, he realized that whatever they are, they're not comets. So he published a catalog of all such objects that he could find, and he didn't discover all of them. He did discover some, but he also took reports from colleagues and other astronomers and published a catalog of things that comet hunters should avoid, as whatever they weren't comets. And so this is number 31, 32, and 110 in his catalog. And Messier 32 is popularly known as Le Gentil, named after Guillaume Le Gentil, the Frenchman who discovered it in 1749. Messier himself never saw it until 1757. M32 is about 3 billion solar masses, has about 400 million stars. M110, farther away, is the only dwarf spheroid galaxy in the Messier catalog. It's somewhere between 4 and 15 billion solar masses and has roughly 10 billion stars. This shows you where they are in the night sky. If you look at the great square of Pegasus, and Pegasus is interesting in that its brightest star, Alpheratz, is also the brightest star in the constellation Andromeda. They share the star in common. Andromeda goes this way. M31, you go to Delta Andromedae and just go straight up. You can also try to go down from the W of Cassiopeia to look for it as well. M31 is a naked eye object and can easily be seen from a dark sky if it's clean and dark. I don't even need binoculars. It looks like a little cloud. And here is, courtesy of Sky and Telescope, this is where you find M31 and the two companions. Again, here's the great square of Pegasus. There's Delta Andromedae going that way. Just go straight up, straight north. Or due south of, I think that's Shadir or Shidar, the brightest star in Cassiopeia. Now, this is an interesting artifact. This is Messier's original drawing of what he saw in the telescope. And he saw M31, and he saw Le Gentil, and he marked that Le Gentil had found it in 1749. And he had He noticed M110, but for whatever reason, he didn't see fit to include it in his catalog. Uh, and it wasn't even added to the official Messier catalog until 1967 at the suggestion of amateur astronomer Kenneth Glyn Jones. Here's all three of them. This is how they look through a telescope of 8 to 12 inches, even 16 inches if you can go low mag. You do need a wide field. You do need you need some low magnification and low power to get all three in one shot. So this is with a 6-inch Newtonian using a 32 Plossl at only 37 and a half times mag. That gives you a pretty good field of view because a 6-inch f8 Newt is that's a long focal length, and longer focal lengths inherently have a narrower field of view. But this is how you can get all three in the same field. In my 16-inch Dobsonian, I have to use a 32 millimeter, uh, 82-degree eyepiece, which is the maximum practical field of view and exit pupil that I can get in that with that large of an aperture. Okay, the next object, this handsome object, is NGC 891 in Andromeda. It's a spiral galaxy, unbarred. The nickname is the Silver Sliver, and it's also Caldwell 23 in that list of observing targets. And after this presentation, because some people are wondering, well, I have all this information, how do I keep that chart? I will make this whole presentation in PowerPoint and my notes available to share and to download upon request. So you can get those star chart snippets, you can get these photos. This is an edge-on unbarred spiral galaxy. And this is very much what the Milky Way, our own galaxy, would look like if we were outside of it, looking at it from this angle, although we are barred. This was discovered by William Herschel on October 6, 1784. It's about 30 million light years away. And this is sometimes called the Outer Limits Galaxy. Those of you might remember an old TV show, I think back in the 60s, late 50s to mid 60s, called The Outer Limits. And this galaxy was featured in the end credits, along with a few other galaxies and objects. So sometimes this is called the Outer Limits Galaxy for that. And that's how it looked in an amateur scope. Again, this is an 8-inch f6 Newtonian, fairly high mag, because that's a 1200 millimeter focal length with using a 10 millimeter eyepiece gives you 120x. It's the faint fuzzy, but you do get the shape. You do certainly get that edge-on feeling. And you'll notice that the URLs of where I found all these are up top here. Jeremy Perez does excellent work. You can search for his sketches on the World Wide Web. You can find them on Cloudy Nights. He does fantastic work, and it's the best way. He and Michael Vlasov, who you'll see later, some of his work, the best way to convey what you actually see in a telescope, as opposed to all those glorious Hubble and James Webb photographs, which will never look like anything that your eyes will ever perceive in an amateur telescope. And here's the location of N891, starting at the Alpha Andromedae, or Alpha Pegasi, because the Pegasus and Andromeda share the same brightest star. My tongue's in a knot. There's M31, by the way. You keep going there's Delta Andromeda, there's the star Myrac, there's the star Almach. These are both fairly visible naked eye stars. Almach is a beautiful double, by the way, well worth looking at. Just off Almach is NGC 891. Speaking of Myrac, this next object is a galaxy NGC 404, known as Myrac's Ghost, because it's so close to the bright star Myrac that when you look at it in a telescope, the glare from the star Myrac almost drowns out the background galaxy. This is a dwarf lenticular about 10 million light years away, and is just outside our own local group. The Milky Way and M31 and 32110 are members of the local group. In fact, Andromeda is the biggest galaxy in the local group. The Milky Way is the second biggest. Myrac's Ghost was discovered by William Herschel, the greatest visual astronomer that ever lived, in 1784. He discovered roughly 2,500 galaxies, nebulas, and star clusters during his lifetime. NGC 404, this galaxy, is intrinsically a bit more luminous, but also a bit smaller than our own small Magellanic Cloud. And it's sometimes has a nickname of the lost pearl because sometimes it's left off star charts because it's so close to the star Myrac they either don't want to print it or just forgot that it was there. Again, this is a valuable resource, by the way, freestarcharts.com. Well worth looking into if you're planning some gazing or planning a target list. You can download and print these out, use them as a guide. Here's the Great Square of Pegasus going on down Andromeda. Myrac is Beta Andromedae, which means it's the second brightest star in the constellation Andromeda. And I misspoke earlier. This star, I think it's called Skeet, or I'm sorry, Menkib. Oh, sorry, Markab. My brain is all over the place. That's Alpha Pegasi, the brightest star in Pegasus. Alpheratz is the brightest star in Andromeda, and it's also a bright star in the constellation Pegasus, one of the few stars that's shared by two different constellations. You just work your way eastward to Myrac, and 404 is right on top of it. And that's how it looks visually. Again, Jeremy Perez doing yeoman work. He got some good separation on it by really bumping up the mag. He used the Barlow. He's going at 240 mag, which that requires a very clean, very calm, very dark night to make that work, especially inside in a Newtonian. It's easier with a refractor because those tend to be intrinsically sharper. But he did you can see the brightness of the star and then the background faint fuzzy. And so our next object in fall, we're just moving right along. There's so much to see. This is not the famous Ring Nebula, M57 in Lyra, though it looks like it. This is actually the Helix Nebula, NGC 7293 in the constellation Aquarius. Because even though the Ring Nebula can be seen in fall, at least early fall, it's much more of a summer object as being part of the summer triangle, those three constellations, Cygnus, Lyra, and Aquila. But Aquarius is a full-on fall-autumn constellation, and this is a planetary nebula. It's roughly 650 light years away, and it's often been nicknamed the Eye of God or the Eye of Sauron, as we will see. This is a Hubble photo in visible light. And for those who are new, a planetary nebula is a star much like our sun that at the end of its life, when it's used most of its hydrogen fuel, sheds off its outer layers of gas and dust, and all that remains is a tiny white dwarf, as you can see here. And this blows out, this expanding gas of dust forms a shell, almost like a double-ended lobe. And we're looking down the lobe. So one day, probably not for 6 billion years or so, but one day our sun could end up looking like this. This is the Helix Nebula in infrared light taken by the Spitzer Space Telescope. And now you can see why it has the nickname Eye of God and Eye of Sauron. That's where that comes from. This photo really helped popularize that. And that's how the helix looks in an amateur telescope. A UHC or other narrowband filter is very helpful, maybe an O3 filter. They're not absolutely necessary. If you have big aperture and a very clean, dark sky, you will see it. I've seen it in 8 and 10-inch scopes, unfiltered. But to get more contrast like this, as in this depiction, a UHC, ultra high contrast filter, really does help, the narrowband nebula filter. And this is Michael Vlasov, who also, along with Jeremy Perez, he does outstanding work in really giving you an idea of what you're going to see in the eyepiece. And even he notes, much easier to see with an ultra high contrast filter. Okay. He was running an 8-inch Newt at low power. So, next, and here's how you find the helix. Again, courtesy of Sky and Telescope. A lot of these can be found online at websites. Just make sure you credit it if you're going to look for it. But here's the constellation Aquarius, it's below Pegasus. And there's a globular cluster M2. That's the brightest thing you can see in Aquarius. Go a little bit south and a little bit east, and you get to the helix, which is again in the new general catalog 7293. This lovely object is called well, it goes by the name of NGC 457, new general catalog number 457. Uh, but it's commonly called the owl cluster or even the ET cluster. Two eyes, torso, feet, one arm, another arm. It's a little ET or an owl if you're so inclined. Those could be considered the wings. Uh, this is about 7,900 light years away and was discovered by William Herschel on August the 18th of the year 1780. It's estimated to be about 21 million years old and has between 60 and 150 members. Open clusters like these are conglomerations of young stars. They're spaced out, but they all formed out of the same original cloud of gas and dust, which is why they're almost family. They were born together and they stayed together until it, after eons pass, the gravitational tides and pulls of the galaxy separates them out. They become just background individual stars. But for the time being, these are very young. Our sun is 5 to 6 billion years old. These stars are only in the tens of millions. They're very young. But one day they will scatter to the background galaxy. And this is how it looks in an amateur scope. And this is very similar to what you'll see even in a good pair of binoculars, but it helps to have a small wide field scope. Here, the mag here is only 77. Again, Michael Vlasov doing excellent work. It's a fairly bright cluster. It's 6.4, meaning it's just outside visual eye range. Even in small binoculars, you'd see it, but you wouldn't see the ET shape. You'd see a smudge. But with any kind of good telescope, doesn't even have to be that large. A 3-inch, 4-inch would do fine. Here an 8-inch Newt at 70, giving 77 mag will give you this kind of view. And here's how to find it. You look at the W of Cassiopeia. Yeah, okay. The brightest star alpha is Shidar. Uh, and between uh, gamma and delta or Rukba, you just go straight down, almost straight south from Rukba, and you'll find 457. And it's worth noting, Eta Andromedae, this star, it's invisible with the naked eye. It's not as bright as the main W, but it's easily visible with the naked eye from any kind of dark sight. And it is a gorgeously colored double star. So next time you're browsing this part of the sky, make sure to check out Eta Andromedae. So moving on from Andromeda to Cassiopeia, this is what we like to call the heart and soul nebulas, more prosaically known IC 1805 or Index Catalog 1805. And the Soul Nebula is called IC 1848 and also IC 1871. IC 1848 refers to this open cluster of stars inside. Again, open clusters are born out of clouds of gas and dust. And these are those clouds. These are both active areas of star formation. The Soul Nebula also goes by IC 1871 for this brighter gaseous region down here, which was detected separately and at first believed to be a separate object. A lot of people are wondering about this alphabet soup. M numbers mean Messier. NGC numbers mean New General Catalog, which was compiled during the 1800s, near the end of the 1800s. And it was a master list of 7,800 plus galaxies, star clusters, and nebulas, trying to systematize a map of the sky. And of course, with all the advances in photography and astronomy, there were more objects to be discovered, at least 5 to 6,000 more. So they developed an index catalog to the NGC. That's why these have IC numbers, index catalog 1805 and 1848 and 1871. As you can see in an amateur telescope, they're not very bright. They're hard to see. It would help to have an ultra high contrast or narrow band filter. But yeah, there would be a challenge. Uh, Aperture helps, but it may not even be determinative. This is only a 4-inch scope, but you're better off having using a lower mag to pull in more light and getting a good high contrast filter and praying you have a very clean, very dark sky because they're hard to see. Uh, but returning to the main image, by the way, this part of the Heart Nebula up here is sometimes called the Fish Head Nebula. I don't really see it, at least on this photo, but depending on the angle of the photo and other exposures, I have seen a little bit more looking like that. But the total distance across both these objects is 600 light years. Like I said, they're active star forming regions. And this area in the sky from here to here is 4 times the size of the full moon. So you'd never be able to fit it all into one eyepiece. Okay. This would you need a wide field camera, and this is probably a mosaic stitched together, or a very low mag wide field image. Get it all. And this is where it is. You have the W of Cassiopeia right off Epsilon, which is the easternmost point of the W. And in case you're wondering, Dixit, what are you talking about? You're pointing to the west. The compass in the sky is not the same as the compass on Earth. On Earth, we go north, south, east, west. However, in the sky, uh, we we consider we flip the east and west. This is east and this is west because things rise in this direction, the east, and proceed toward the west. So star charts are drawn that way. So north and south remain the same, but going this way on a star chart, this direction is east, that direction is west. So heading east from Epsilon Cassiopeiae, pardon me, you get the galaxy NGC 1027, and you get the heart and soul right there. This lovely object is known as Caroline's Rose. It's another open cluster of young stars. Now it's a little bit older. It's about 1.5 billion years old. Still young as far as stars go, but much older than your typical open cluster. And you're wondering, why is this called Caroline's Rose, which is a much nicer name than its official designation of NGC 7789. It's named after Caroline Herschel, the sister of William Herschel, and she discovered this object in the year 1783. William was the greatest visual observer of all time, and he was a prolific telescope maker. He made her a few scopes so that she would assist him with cataloging and recording his observations, but she also did observations and searches herself. And William built her several lower power, small aperture, but wide field instruments so that she could search for nebulas and clusters herself. This is one of the ones she found. It's 8,000 light years away. It's about 50 light years across. It has an estimated 1,000 members, and the total brightness of all stars combined is estimated, if you could add all their brightness together, it would be 3,000 times that of the sun. There's Caroline's Rose, as seen in a telescope at moderate power. 61 is on that. It's on that. It's a little bit more than low. It's pushing medium. Uh, so this is a small refractor, uh, wide field. That's the best way to see this object. If you zoom in too much with too high of a mag, you'll get individual stars, but you won't get a sense of a pattern or any sense of clustering. And here's how to find it. Here's the W of Cassiopeia, and in between alpha and beta, this is Shidar, and that's beta Cassiopeiae. If you were to draw a triangle, almost like a Well, it's not a right triangle, but it's a semi-triangle with Alpha and Beta Cassiopeiae. That'd be how you would star hop to it. This interesting object is known as the Skull Nebula. Uh, it's NGC 246. It's a planetary nebula in the constellation Cetus. We've now left Cassiopeia and we're on to Cetus. Cetus the whale. And anyone here, if they're a fan of the movie Clash of the Titans, you may be wondering, we've heard of and we have the constellation Andromeda. Now we have Cetus the whale. We have Cassiopeia, okay, uh, who was the mother of Andromeda, and Cetus the whale was also in mythology the sea monster called the Kraken in the Hollywood treatment. And if you're wondering, well, where's the hero Perseus? Don't worry, he's coming later. But astronomy, a lot of astronomical terms and names of constellations have their roots in Greek mythology. Anyway, this is another planetary nebula. This is a star similar to the sun that reached the end of its life and blew out its gas and made a shell, an expanding shell. It was discovered by William Herschel in 1785 and is roughly 1,600 light years away. There's how it looks through an amateur scope. Uh, it can look skull-like under very clean, dark skies. I've seen it personally looking like this, but then with two tiny dark spots that give the impression of eyes. This is an 8-inch newt at moderate power. In order to see the skull, you need dark skies, and I was using I was using 10 inches, had a little bit more oomph to my view. Uh, but it does look like a skull if you're in luck. Here's how to find it. I had to highlight it here. Here's the constellation Cetus, which is not the brightest of constellations. But if you can find the shape, it is right almost due north of the brightest star in Cetus, Alpha Ceti. This imposing object is NGC 7331. It's a favorite of mine. It blew me away the first time I saw it. It's a large spiral galaxy, unbarred, in Pegasus, because now we're on to Pegasus. Again, that ties back to Greek mythology, the flying horse. And if you watch Clash of the Titans, Pegasus was the flying horse and the steed of the hero Perseus, who's coming next. It's also called Caldwell 30 for those who are into observing the Caldwell objects. And the nickname is the Deer Lick Galaxy because it's the heart of what they call the Deer Lick group, these other small galaxies around it. 1731 is by far the biggest and brightest of them all. It's about 40 million light years from us. It was discovered by William Herschel in 1784, and it's about 120,000 light years in diameter. It's a big galaxy because the Milky Way itself is 100,000 some odd light years in diameter. So this is a large object. As seen in an amateur scope, here's the entire Deer Lick group. The professional photo before had been rotated to look more normal. When you look through a scope, 1731 is always at a sharp, almost vertical angle. And you can see the other faint fuzzies that make up the rest of the Deer Lick group and their corresponding NGC numbers. Okay. Here's how to find it. Here's the Great Square. At the top of the square, the northern end of the square, here's Alpheratz. Going east is Andromeda. Here's the constellation, it's the star Beta Pegasi, the second brightest star in Pegasus, called Skeet. You head north and you head west, or if you can find in a dark sky, you'd be able to see it. Star Matar, Eta Pegasi. Go almost due north of Eta Pegasi, then slightly to the west, and you'll find it. Now, what on earth are we looking at here? This is a very famous group of galaxy called Stephan's Quintet. It's also in the constellation Pegasus. Pegasus is rich with galaxies. It's a visual grouping of 5 galaxies. 4 of them are actually close to each other and gravitationally interact with each other. The fifth is just that's an optical illusion. It happens to be in the same field of view, but it isn't anywhere close to them. Uh, so the average distance of these is about 290 million light years away. But this one, I believe it's this one. We'll find out. That's only 39 million light years away. It just happens to be in the same field of view, but it's not related. Uh, this grouping was discovered in 1877 by astronomer Edouard Stephan at the Marseille Observatory in France. That's why it's called Stephan's Quintet or Stephan's Quintet. It's the most studied of all compact galaxy groups. It's the first compact galaxy group ever to be discovered. Uh, and the brightest member, again, is this. Oh, this one. That apparently is the brightest one. It's only 39 million light years away. Easiest one to see. These others, the other four, and this is two galaxies. It's not one. It looked like one galaxy to the people who first saw it. It's really two galaxies that are very close together. They're basically crashing into each other the way we're going to do with Andromeda. These are all about 290 million light years away on average. Uh, and so a lot of you have probably seen the movie It's a Wonderful Life. It's a little early, and it's not Christmas yet, but it's coming. But that's just an all-time great movie. And who could forget during the movie the angels? When Clarence, angel second class, came as a little star, he would be talking to the Joseph and the other angels. They would talk and they would glow. That was an actual photo from, I believe it was the Palomar Sky Survey, the older one, that some Hollywood exec found and decided to use that to depict the angels. So that was from an old astronomical catalog, and Hollywood used it to depict the angels. And here's that Stephan's Quintet. That's all they could see back in the day. The telescopes and cameras just couldn't do uh, what we did. One, two, three, four, five. Uh, Here's a combination of a Hubble view, and the Chandra, which is an X-ray telescope, merging their data. And yeah, we've come a long way. And of course, one of the very first images released by James Webb when it came online, one was a deep field, the other was a gaseous nebula. But one of the first five images, they released that suite of images from Webb going online, was an image of Stephan's Quintet, and this is an infrared data. So this is an object, HCG Hickson compact group number 92. It's another designation for this conglomeration of galaxies. It's truly remarkable, but as you can see, it's faint. Okay? There's a reason why astronomers use the term faint fuzzies. Okay, Mr. Perez, again, do check out his site. It is just you can get down, you can go down a rabbit hole just like you can with Michael Vlasov, but it is absolutely worth checking out. And he really bumped up the mag. I'm surprised that an 8-inch even covered it. He must have had super dark sky because to see these, I would not feel comfortable with anything less than 10 inches of scope, and even in 16 inches of scope, which I have, it can still be a challenge to get this good of a view, although he only sees one, two, three, four. He can't distinctly see the double nucleus. Uh, it's a tough thing to see, but it's definitely worth trying for, and fall is the time to do it. So get yourself out to Blue Canyon when it's dark, bring your biggest scope, and put your eyes to the test. So here's how to find it. Again, these sky and telescope maps, they're found in the Sky Atlas 2000 or in the Pocket Sky Atlas. Both are publications by Sky and Telescope. Excellent charts. Again, you go look at the Great Square of Pegasus off Beta, and you just drift northwest. Here's Gamma Pegasus. No, I'm sorry, Eta. Eta, that's not a Gamma, it's an Eta. So very close to Eta Pegasi and almost due west. uh, and then due northwest of Omicron Pegasi. So you can plan your star hop based off that. Now, what's this amazing object? Staying in Pegasus, that is globular cluster Messier 15. Now, what's a globular cluster? It's the polar opposite of an open cluster. The open clusters we saw before, those are young stars, very young. Uh, a globular cluster, these are some of the oldest stars, not just in the galaxy, some of the oldest stars in the universe. Uh, this is roughly 35,000 light years away, and it's 100,000 stars packed together in a tight ball. That's what makes them stand out like cotton balls in the sky. They are bright just because you pack so many stars into such a tight space. It's going to have a high luminosity. This object is about 12 billion years old, and it's 360,000 times brighter than the sun. It's 175 light years across in this Hubble photo, and it's one of the very few non-galaxy objects. Again, it's not a galaxy, it's a globular cluster. They've identified a black hole at the center of it. It's an intermediate-sized black hole, about 4,000 times heavier than the sun. It's not the supermassive black hole that you see at the center of big galaxies. Uh, and this object was discovered by Jean-Dominique Maraldi in 1746. And Messier, he recognized that. He just put it in his catalog. Again, Messier did not discover all 110 Messier objects. He discovered a bunch of them. Uh, and then he put observations from others in his catalog to tell comet hunters what to avoid. Here's another Hubble view of M15. It's a bit more wider field. This is a bit closer to what you would actually see in a telescope. Of particular interest is this little blue dot here. That's called PEAS, P-E-A-S-E 1. Uh, it is a planetary nebula. One of the stars is a planetary nebula. It is the first planetary nebula ever to be found inside of a globular cluster. And that was discovered back in 1928. And since then, only four other such planetaries inside globular clusters have ever been found. That's how it looks in a typical scope. It's always a good sight. And you have very low mag. Even in a finder scope or binoculars, you'll find it. It'll look like a cotton ball with no detail. But if you bump up the mag, this is only 83 mag, although it's a 12-inch telescope. Uh, but even an 8-inch telescope, bump up the mag to say 100, you will resolve individual stars. You will see individual pinpoints of light within. It is an outstanding object. It's always a highlight in the autumn sky. It's one of the first things I look at when I set up my telescope in the autumn, because I do have a 16-inch go-to telescope. What that requires is I have to align it on two or three bright stars. So I'll pick bright stars, center them, get the computer aligned. Then I'll test it out by saying, take me to M15. And if I get M15 in the center of my field of view, I know that my alignment and my calibration was done correctly. There's how you find, here it is. Here's the great square of Pegasus. And here's the head of Pegasus. The head is upside down. Okay, those are supposed to be the front legs. But here's Alpha Pegasi, Markab. You go out to basically the front of his head. You have a star called Enif, Epsilon Pegasi. And if it's dark outside, Enif is easy enough to see. It's a fairly bright star. And M15 is just to the northwest of Enif. Okay, so it's not too hard to star hop to. If you get your finder scope on Enif and then drift a little bit northwest, you should get the finder scope aligned on that little fuzzy cotton ball. Then you'll see it in your main scope. This lovely object is another Messier. It's Messier number 76, called the Little Dumbbell Nebula, as opposed to Messier 27, a summer object, which is just the plain Dumbbell Nebula. This is smaller than the famous M27, but it's still a striking sight. It's a planetary nebula. Again, the sun might end up like this billions of years from now. It's a star that died, a regular sized star that died, leaving a white dwarf at the center and an expanding shell of gas and dust. About one and a half, I'm sorry, 1.25 light years across this way, that way. It's faint and it can be a challenge. Everyone always says the Messier objects are the easiest things to see in the sky. And granted, they're easier than, shall we say, a lot of IC objects, but not every Messier object is a cakewalk. This is faint. This can be challenging. It's one of only 4 planetary nebulas in the entire Messier catalog. And it wasn't discovered by Messier. It was discovered by Messier's colleague, Pierre Méchain, on September the 5th, 1780. In an amateur scope, again, thank you, Mr. Vlasov, he bumped up the power to 125. Uh, it is faint. That's about, I would probably stick to 100 power because the higher the mag, you do darken the background, get more contrast, but you lose a little brightness. So I would probably go out 100 in an 8-inch scope. But this is a very fair representation of what you'll see given a, this is almost always a given, or not a given, it's a given requirement. You should always have a clean, dark sky. You get a clean, it's better to have an 8-inch telescope in a clean, dark sky than a 16-inch telescope in a crappy, murky, windy, dust and smoke filled sky. So Mr. Vlasov is observing from the deserts of Israel. So imagine it gets pretty dark out there, which would be always be an advantage. And here's how to find Messier 76. Again, this is in the constellation Perseus as opposed to Pegasus. We moved on from the flying horse to his rider, the hero Perseus, the one who saved Andromeda from the monster Cetus. So it's away from the main body of Perseus, out toward his westernmost outstretched arm. You'll find in Messier 76, you can star hop from the double cluster, which is something we're going to cover later. But you can use the double cluster as a mark. Hey, that looks like home. This is the California Nebula, NGC 1499. It's 1,000 light years away, and it's about 100 light years long. And there's some star formation here, but a lot of the emission is caused by heat from this bright star, Xi Persei. The heat from this star is causing the gases here to react and glow. Not reflect, but actually glow. This energy is causing the hydrogen and sulfur here to emit light. Here's a narrowband image, which appears to be an H alpha and H beta light. And that's what yields a different color palette, but it uncannily does look like the Golden State. And it's a very faint, very difficult object to see. You need some sort of filter. Probably use a very good UHC filter, or better yet, use an H beta filter. It's one of the 5 objects. You can actually use an H beta filter on your eyepiece that would actually help. The other most famous one would be, of course, the horse head. But yeah, it is not easy to see. This person going from the dark skies of Arizona, Mount Graham is a dark place. This amateur used a small telescope with an H beta filter. Good on him. Very low mag, very wide field of view. That's probably the right way to go about doing it. If I were using my 12 or 16-inch, I definitely would use the H beta. I can't get as low as 17x just due to aperture, but I'd use, again, as low and as wide fields I could get. I would use, say, nothing more powerful than a 20 millimeter. I'd probably use my 32 millimeter 82 degree for the maximum possible field of view and lowest possible mag. Just trying to nab this object. It's actually something that this is on my bucket list. I have never seen this object visually. I'm going to try, maybe at Starbecue. And by the Gergo, count me in for Starbecue, weather permitting. I'd like to be there. I'll bring an easy up. I'll help set up. I have some things I want to offer for the raffle, so I'll let you know.
Thank you. Awesome.
Here's how to find. Here's how. Do you know the way to San Jose? Well, I don't know about that, but I know how to show you. I know how you can find California. This is in the leg of Perseus, uh, just below Epsilon, and between the next brightest star below Epsilon. Okay. Our next object, and trust me, we're getting close. I'm not going to talk all night, but I try to have a good selection and variation of objects. We have another open cluster here. This is Messier 34, yet another Messier object. It's in Perseus. It's 1,500 light years away. It's a younger cluster, about 200, 250 million years old. Has about 100 members. Blue, the bluish tint, blue stars are younger stars. Discovered by the Italian astronomer Giovanni Battista Hodierna before the year 1654. Messier himself found it independently on August 25th, 1764, and he added it to his catalog. It's an excellent object in binoculars and small scopes. So in binoculars, you probably won't resolve this many stars. It'll look more like a cloud or a patch light. But through even a medium scope with medium mag, you will see a whole bunch of different colored stars. And here it is. Again, here's the body of Perseus. And the most famous star in Perseus is the demon star Beta or Algol, Beta Persei. Just drift west and a little north, and you'll get to it. Or we're coming to the double cluster. We're going to get there, but if you find the double cluster, just just keep going south till you get there. Speaking of, that's the double cluster. It's two open clusters, NGC 884 and NGC 869. I'm sorry, 864. 864 is a denser one. 884 is a little bit more coarse. It's a fine object. This is naked eye visible. You get out to Blue Canyon or a dark sky on an autumn night, and you look up at the sky, you will see, you won't see two, but you'll see, it looks like one large patch of light. You might mistake it for a stray small cloud, but it is definitely visible if you are looking in the right spot. These clusters are related. They do interact gravitationally. They're both about the same distance away from us, 7,500 light years or so. But they're only 13 million years old. These are young stars. And between them, there are over 300 blue-white supergiants. And blue-white supergiant stars, by definition, are young because blue-white supergiants quickly burn out and go supernova. They burn through their fuel so fast. This is Caldwell 14 for those who are trying to finish their Caldwell catalog observing list. And again, it is naked eye visible. Yes, 869 is again more dense. This is more densely and packed together. 884 is a bit more coarse. Again, Mr. Vlasov did excellent work. This is a very good depiction of you need binoculars or low power. You can see it in a big scope. Just use low power, wide field. There's a 864 and there's 889. Keep saying 869 and 884. I'm sorry. 864, 88, yeah, 864 and 889. Okay, here's how you find it in the sky. Is between the body of Perseus. It's technically within the constellation boundary, but here's the main body of the heroes over here. but it's between his outstretched arm and the W of Cassiopeia. So just look at this region of the sky. You'll see if you see what appears to be a faint cloud, you know what you found. You know you're looking at the double cluster with your own eyes. This is our second to last object. This is galaxy NGC 253, also called the Sculptor Galaxy, because it's in the constellation Sculptor. And also the popular nickname for it is the Silver Coin Galaxy. It was discovered by Caroline Herschel, William's sister, in the year 1783. This is the first galaxy ever to be discovered by a woman, and she was the first woman to ever discover a galaxy. This is about 11.5 million light years away and about 120,000 light years across. It's a big galaxy, Milky Way in the Milky Way's class. And that's how it looks. If you have a good dark sky and good optics, it helps to have some aperture here. You can see texture and mottling in it uh, if it's under the right conditions. Uh, Here, an 8-inch with a 13 millimeter was used, giving 77 mag. I might go a little bit higher than that, uh, maybe say 100, but it's a fine object. Just be sure to, because it never gets that high, unfortunately, from here in Sacramento. It's always kind of close to the horizon. Not enough that it blocks you from seeing it, but you don't always get the mottling in detail. But if you can, on a fine night, clear and dark, it's absolutely phenomenal to look at. Here's how to find it. Here's the very nondescript constellation Sculptor. Probably your landmark would be this bright star, which is in a different constellation. This is the star Fomalhaut in Piscis austrinus, the southern fish. This is a fairly barren-looking area of sky. Uh, Unless you're at Blue Canyon, you don't see a lot going on here. Even at Blue Canyon, you'll notice stars, but they're all going to be faint. Fomalhaut's going to be the only bright star in the area. So, from the brightest star on the Sculptor, Alpha Sculptor, you work your way north and just slightly to the west. And you can't even star hop. There's almost nothing in the middle. So, all right. Last one. As you all sigh in relief. We have another Messier object, a galaxy, Messier number 33. This is in the constellation Triangulum, which otherwise has nothing interesting about it other than this object. But this is the third biggest galaxy in our own local group of galaxies. It's very active. It's small, but all these reddish regions, these are active of intense star formation. Uh, so roughly 3 million light years from us. It's about 40 billion stars. So the Milky Way has 10 times more stars than this thing does. It's roughly 61,000 light years across. Again, the Milky Way is 100,000, maybe a little more. Apparently, it was discovered again, before the year 1654 by Italian astronomer Giovanni Battista Odierna, because he called it a cloud-like nebulosity near the constellation of the Triangle, which almost could only be this. Messier found it independently and cataloged it on August the 25th, 1764. These bright regions, they're called H2 regions because of double ionized hydrogen gas, which gives off a red color, characteristic of heavy star formation. Especially this one right here. This actually has its own NGC number because when people were looking later, they thought it was a separate object. They didn't realize it was part of a Galaxy M33. And this knot, if you zoom in on it with Hubble, that's what you get. Uh, this is a large open cluster with huge clouds of gas and dust surrounding it. If this thing were where our own Orion Nebula is now, we would see it during the daytime. It would dominate the sky. It would be amazing. Uh, and if you look at it, it's a surprisingly hard object to see because its surface brightness overall is pretty low. Theoretically, this can be seen with the naked eye. Vlasov claimed he saw it with the naked eye from the deserts of Israel. That you'd have to be somewhere similar because I have tried from Black Butte, from Cronin Ranch, from Blue Canyon, from the darkest skies I can find. I have never gotten close to seeing this with my own eyes. And even in a telescope, you could be staring straight at it and miss it because the surface brightness is low. You don't want too high of a mag, you don't want too low, you want a medium mag to optimize to get the best balance between darkening the background and contrast, yet keeping enough light gathering to see it. Uh, but on a good night with a big telescope, you discern a little bit of a hint of spiral structure, and you see that he didn't see the big knot 604, but he sees some of the smaller H2s. I've seen that 604 knot from Black Butte in a 16-inch telescope. You can see it if the conditions are right. And here's how to find the Triangulum Galaxy. Here's M31. So you keep that is the star Myrac. So Myrac, and then there's Almach, the last bright star in Andromeda, forms kind of a triangle with those two bright stars. Triangulum itself is so nondescript, I have a hard time even finding it, even though it's close, even though the brightest star in Triangulum, Alpha Triangulum, is close to M33. I look for these stars in Andromeda and try to finagle my way there, uh, doing it that way. So, as you can see, the universe goes on and on and on, and there's still so much more to explore. But don't worry, because my next talk is going to cover every single one of these in detail. So, thank you, ladies and gentlemen. I do hope you enjoyed that. That concludes the presentation.